this is 5.5 Bonding Structure and Properties Review Sheet. So use this as the start of your revision or to help you revise. So the first thing this review sheet asks you to do is to recap on what you already know about the atom. So name the three particles that make up an atom: proton, neutron and electron. Then to draw and label an atom. So you've got your nucleus in the middle with your positive protons and your neutral neutrons. Then you've got your shells with your electrons on them. Then it asks you just to, again, a recap, because this is something you did in core chemistry, to look at the charges. Protons are positive, electrons are negative, and neutrons are neutral. The mass, and remember the majority of the mass is kept in the nucleus. So you've got mass 1 over 2000, which means it's tiny, and then 1 again. Where are they kept? So the protons are kept in the nucleus, electrons are kept in the shells, and the neutrons are kept in the nucleus. Again, a bit of a recap from core chemistry. What does the atomic number tell you? The number of protons. Okay, the number of protons equals the number of electrons. So if it is an atom, you've got equal number of protons and electrons. What does the mass number tell you? The number of protons plus neutrons. So what is in your nucleus completely. So the first type of bonding we're going to look at now is ionic bonding. Ionic bonding is the transfer of electrons, between a metal, so metals tend to be in group 1 or group 2, and a non-metal. So non-metals are group 5, 6, 7, and then group 0. So you've got magnesium, which has got 2 in its outer shell, and oxygen that's got 6 in its outer shell. So magnesium is transferring these 2 electrons to oxygen. Magnesium has lost 2 electrons, so has become 2 positive because it's lost 2. Oxygen has gained 2 electrons, so it's become 2 minus, okay? They have really strong bonds because there's a really strong bond between this positive charge and this negative charge. So they've got high melting and boiling points. They are really hard to break them bonds. Other examples would be sodium chloride, which is a salt, and potassium chloride. Moving on to the other type of bonding that you need to know about, covalent bonding. Covalent bonding is the sharing of electrons. Okay, so this is how water, it tends to be non-metals. So non-metals, group 5, group 6, group 7, and then group 0. Non-metals tend to bond this way. So as you can see, hydrogen's got 1, 2 hydrogens, oxygen's got 6, so they share them electrons. The sharing of the electrons ends up in them shells there, and then you've got your free electrons as well. 2 other examples of covalent bonding: methane, and then all diatomic molecules. So anything in group 7, oxygen, nitrogen, and hydrogen. Diatomic means they exist in pairs. The final type of bonding you need to know about is metallic bonding. Metallic bonding is the bonding in metals, so just bonding that exists in metals. As you can see here is an example of the bonding in zinc. So zinc basically offshoots its electrons, so they end up free to roam. So you've got a positive ion in the middle, which has got your charge wherever your zinc charge is, and then you've got your free electrons, which are free to roam around that positive ion. This creates a large electrostatic force between the free electrons and the positive ions. So it's a massive force here, which is really hard to break. It's one of the reasons why they can conduct electricity and heat, because these electrons move and transfer the electricity down the metal. Malleable and ductile, because these electrons can move, which means they can be bent slightly. You will be asked in the exam to explain the properties of different types of bonding. So ionic compounds have got really high melting and boiling points because the electrostatic forces between the positive and the negative ions is really hard to break. They can be very brittle though, which means they're easily bendable, they break apart. Simple covalent molecules, so covalent molecules only contain a couple of elements, mostly gases at room temperature, low melting and boiling points because they've got one bond. They do not conduct electricity because there's nothing free to move. Now, giant covalent molecules are things where they've got, so say if water bonded over and over again, loads of covalent bonds in the same space, high melting and boiling points, solids at room temperature, and they have got numerous bonds. Okay, so they've got a little bit of a higher one. These are the ones that have got the highest melting and boiling point, the ionic compounds. You can have giant ionic compounds, which means that they bonded over and over again, which again increases the electrostatic force. So some other things, and then you need to know a little bit more detail about certain giant covalent molecules. So diamond, high melting and boiling points, regular lattice, they've got 4 carbon bonds, so each carbon is bonded 4 times, no free electrons. They're all covalent bonds. Graphite and graphene can conduct electricity because they've only got 3 carbon bonds, which means that there's 1 free electron free to conduct the electricity. Graphite is layers which slide between them, weak forces between them. Graphene, which is essentially just 1 layer of graphite. So you add graphene over and over again to make graphite. It's got really high melting points because of the delocalized electrons, which means the electrons are free to move. Delocalized means they aren't stuck in a place. The other one you've got to know about carbon nanotubes is graphene. So instead of putting on layers to make graphite, you can roll it up into a tube, and they've got really high tensile strength. They're really strong, so they've got quite a lot of uses. So that's all the bonding stuff you need to know for this topic. The other things you need to know about, one is nanoparticles. So what is a nanoparticle? They are tiny particles. They are 0.1 nanometer. That's how small they are. Uses of silver and titanium dioxide. So silver, antimicrobial, so used in socks, and antibacterial, again used in your fridge. Titanium can absorb UV, so it's used in sun creams. What is the difference between the nano silver and the bulk silver? They have a larger surface area to volume, so they're a much larger surface area to act on, and they also have different properties. So bulk silver has got completely different properties from nano silver. What are the problems with nanoscience? It could be toxic, and they're so small, they could be breathed in, or they can get in our drinking water. Finally, the last thing you need to know about is smart materials. So, smart materials change property based on external stimuli. So if it gets heated up or there's extra light, they change their properties. How do thermochromic pigments work? They react to heat, so they change colour. What other examples of smart materials can you give? Hydrogels, they absorb water 10,000 their weight or their volume, so they're used an awful lot in nappies, and shape memory polymers, stuff like braces, retainers.